So for today, it is about trig identities, and we're going to be focusing on factoring and using common denominators. All right, so there's a few things that I want to make sure you remember. Like, how do you do a common denominator for something like this? Like, if you can't do it when there's simple, then how can you do it when there's trig involved? So this is kind of one of my themes for math, is like you got to understand your basics or you can't understand the new stuff. So let's go way back to just this. Everybody write that one down. 1/2 plus 1/3. You can't add unless you get a common denominator. Okay, George, copy that down. Your hand doesn't move, so that's how I can tell you haven't yet. Thank you. So we're going to get a common denominator. What is a good common denominator for these? Probably 6, right? Because you just multiply them. So basically, you multiply by the other denominator. Now, there's more complicated ways to describe this. Because if this was 30, you probably wouldn't want to use 60 for your denominator. But 60 would work. 60 would work. So my point is, I think that we should just teach kids to always multiply the two denominators. So multiply by that other denominator. And then you'll have 3/6 and 2/6 makes 5/6. At the end, notice we did not multiply 6 times 6. At the end, you're adding things that have a common denominator. Just the tops get added, 3 plus the 2 made 5, but these just stayed the same. All right. Well, let's do it when it's just got one variable in it. That's the next level of complexity. 1 over n plus 2 over 3. What does that add up to? Well, get a common denominator. And in a minute, these are going to have trig in them. And we'll need a common denominator. Thank you. Last chance to get those cell phones put away, get focused in, laser focused. Banana bread could be out though. That's all right. That stuff's good. You know what's better? Banana bread made in Hawaii. They're big on banana bread there. And you drive in Maui, you drive way off into the wilderness, and there'll be these little shacks along the road that are selling banana bread. This first lady who did it, she started this tradition 20 years ago, and she was like, all these people drive past my house, I could just put out a little stand and sell banana bread. And she started doing that forever ago, and she was like, oh my gosh, I sold out. I sold even more. She started making 30 loaves a day and cutting them into slices and selling a slice of banana bread. And I went past there. She's gotten so old that she doesn't stand out on the road anymore, but her daughter's out there, and sometimes they just hire people to stand out there. And kind of be interesting to track the inflation on it. The banana bread loaf, now they don't sell slices anymore, just the whole loaf. And it's $25 for a loaf of banana bread. Because they're the famous one. They're the one that started it first. Everybody else sells it cheaper, but. All right, so did you multiply by n here and here? And did you multiply by 3 here and here? And then this is 3n and this is 3n. That's the whole point. Now we got a common denominator of 3n. And then out about the top, 3 plus 2n. You can't add those. If you thought that was 5n, no. They would have to both have an n. 3 and 2n just can be put like this. There was your final answer. Be honest. How many had exactly that? Okay, good. That's most of it. If you didn't, maybe you thought somehow you could make that 5n, which I get the mistake. But. Okay, then we're going to turn it into trig. So 1 over cosine plus 2. Well, what are you even talking about? That doesn't even have a denominator. Oh yeah, I guess it could have a denominator, couldn't it? A denominator of 1. In a moment, I'm going to ask you to show the kid next to you what you think the final answer is. Same deal. You're multiplying by the other denominator. And your answer will be like something plus something over something. It happens a lot. You compare with the kid next to you. I am going to take attendance. So pause it for a second here. Okay, so you multiply by the other denominator. This will be cosine and cosine. And this will be 1 and 1, so that's kind of irrelevant over there, right? So then I just take 1 plus 2 cosine. 1 plus 2 cosine. All over cosine, cosine, you just put cosine. Again, you don't add the bottom, you just keep the bottom the same. Again, it really helps me to know whether I should stay and do another or move on. How many of you had it exactly right? That's the vast majority of you. Okay, good. So you get common denominators, even in the context of trig. All right. So then let's do factoring again. Just plain old-fashioned factoring. I hope this is like, oh my gosh, that's so easy, Mr. Server. Please just remind me that you know how to factor, because in a second it's going to be trig that's getting factored. And again, this is why I stress these things like top 20, because if you don't know factoring, then when we get to the factoring part of trig, you're stuck. X and X. I always think the next thing is the signs. So you look here, and since that's negative, I know it has to be a plus and a minus, period. Now, something multiplies to 4. Well, it's not going to be a 2 and a 2 because that won't make the 3. So it must be a 4 and a 1. And then I just got to look. I want a negative 3 left, so let's make the bigger number negative. And if I'm not sure, I just multiply it out quick. This times this, x squared. Outside and inside is where it's all at in the lasts. And then this does make negative 3. Yay, I did it right. Okay. So why'd I do that? Because you're about to factor this. Cosine squared minus and I know that looks really confusing, but trust me, we just have to know how to factor. And it's just factoring again. So you're going to have something in the front that has to make cosine squared. I bet most of you just figured out that's got to be cosine and cosine. Does that make sense to you? Okay, good. And then because it ends in a minus, there must be a plus and a minus. And last but not least, because this is a 2, the only way to make a 2 is a 1 and a 2. The only two choices are, it could be a 2 and a 1, or it could be a 1 and a 2. I'm just not sure which one goes where. And then I think about it, and I wonder, my gut says that the 2 should be negative. So I think it should be this one. But how do I tell? You multiply it out. Would you take a second, please, and multiply this out? Actually multiply it out. First, the outside ones, the inside ones, and the last ones. Some of you don't do it that way. That's okay. But it's got 4 parts no matter what. And the first ones you always multiply, and the last ones you always multiply. Some of you do the others in a different order, and that's fine. I call these the outsides. This is the insides. 1 times anything is just that. And then the lasts. And this is the weird part. And if I want to put a 1 in front of that, it's easier to understand that this is negative 1 cosine x, which is the same as negative cosine x. And look at that. It worked. That's what I had in the first place. And I multiplied it all out, and that's what I have again. And That was just, all of that was just me checking to make sure that it was working. Now I'm gonna erase that stuff. It worked. So now what? What's the point? Why would you factor this? Well, sometimes it's to get a common denominator, like we just talked about a minute ago. Other times it's to actually solve it. So just take a second and watch me. That's almost never say that, but just watch this. If I said cosine x plus 1 has to equal 0, do you get, if I make this equal 0, then the whole thing would equal 0? That's why I'm making it equal 0. And then do you get if I subtract 1? All of a sudden I'm left with a trig problem. Cosine of x equals -1, and we've done that one. It's a quadrantal. Does that ring a bell? And then I could solve it by doing, okay, it's one of these quadrantals. Did I see an inverse trig in there? Nope, I never used inverse, so I don't have to worry about those restrictions. So where's cosine negative? Well, definitely not there. Everything's positive there. A, S, T, C. See how it's all coming together? Now all of a sudden you start with a trig equation, and you have to know identities to be able to factor it down and go, okay, well, I know that this must be factored into this and this. And then you have to know how to do circle trig to get it down to this. And then where's cosine negative? Well, it could be here or here, and so therefore there could be two different answers for this, and I'm not even going to finish it. Well, I guess I may as well. Cosine is negative. Remember, cosine is x over r. That's another thing you have to remember. So cosine is really the x. So which spot is it? I feel like it's this one, but I'm going to make sure. Cosine is x is -1, and that's where x is -1, so it's definitely that spot. And then if the answer to this thing is an angle, remember, that's an angle, and I don't know what it is. That's why it's a theta, or an x. So then the answer is the angle, and the angle is pi. So the answer to the whole thing is pi. Intense, huh? All right. Side note, this one, again, not asking you to do it, just watch me for a second. As soon as I add 2 to both sides, you might be like, we have never done cosine of x equals 2 before. That's because it can't. If you look at the graph of cosine, you remember graphing these? We did them for a while. What was the highest cosine ever went? 1. So if I said cosine is 2, the answer is never. No solution on that. Because cosine's highest it can ever be is 1. So this part's got no solution. This part's answer was pi, so my answer to the whole thing was pi. All right, now that's a long time from now. Our test isn't until right before spring break. And we got 2 weeks. So I'm not saying you have a whole 2 weeks, but we've got a bunch of time before you have to be able to do what I just did. But all it really does is tie together circle trig and identities, and then all you really have to do today is to be able to get common denominators and factor things. Let's do one more factoring. Better write this down. 1 minus x squared. Normally I say x squared minus 1, but on purpose I switched it around. Can you just factor that? Jack, what goes in the first positions, here and here? Nope, you don't switch them around. Leave them in the same order that they're in. The 1. Yep. Because 1 times 1 makes 1. And then, judging by the fact that the end of this thing is negative, Jack, what does that tell you about the signs? Plus and a minus. And then, seems logical if we got to get an x squared to come out, that it's probably x. And that is the right answer. Just to be sure, watch. 1 times 1, 1 squared. That's just 1. Outside and inside is really where all the action happens. Minus x and plus x, and those disappeared. Last one's minus x squared. These knock each other out. I'm left with 1 minus x squared. That's what I had. It worked. All right, so let's try it again, except this time with trig. 1 minus cosine squared theta. Can you factor it? This is why I was trying to get your basics strong before now, so that factoring part's easy. Because now it's got all these weird trig words in it. Okay, compare with what kid sitting next to you. See if you factored that right. Okay, Claudia, what did you think it was? And remember the theta.
Yeah.
Okay.
And then 1 minus cosine.
That is correct. That's all there is to it. It's factored. Okay. So, watch out for factoring. It's going to happen with trig now. Watch out for common denominators. It's going to happen with trig now. All right, with that, I think these slides won't be that bad. If I had just said factor this, I think a lot of you would have been like, what are you even talking about? But now we did a couple, I think it won't be that bad. Just think logically. It's got to have cosine in it. It's got to have pluses or minuses. And it's got to end with a 1. There's not that many combos that could work here. And if you think you're right, you can just multiply it out quick and see if you are. All right, I'll pause while you try this one. Did you have cosine and cosine? Because multiplied together they make cosine squared. And you have to end with a 1 and a 1, because 1 times 1 makes 1. And they either have to both be pluses or they have to both be minuses. And I hope you used logic and said, well, they can't both be pluses because then we'd never get a negative. We have to use both minuses. And then if you want to be really sure that it worked, you go that times that, cosine squared, outside -1 cosine x, inside -1 cosine x, which together makes -2 cosine x. And then the -1 times the -1 makes +1. I know it works now. So those together make that. Yay, I factored it right. Okay. How about this one? Now, this one is weird because you have two functions. Let me tell you, you're not going to factor it unless you can get it down to one function. So if I just gave you this, honestly, only 2 kids in the whole room is probably, even after 10 minutes, going to figure this out. But I'll give you a little help. Would you agree that if this one was cosine, then it kind of would look like the other one just rearranged, if this was a cosine? So then that's what you should tell yourself is somehow I have to change sine squared into cosine. Do you get if that was cosine? Then we could factor this thing. So that's what you have to do. So then you go to your sheet. Now I know I gave them to you. I know half of you are going to have lost it. And some of you want the digital version. Totally fine. Find the digital version. Put it up on your iPad. So either, I think the little paper sheet would be really handy, and that's what I'd have. And I do have extras if you have lost yours. But please don't do this to me every day. I have enough extras right now. So either have it up on your iPad or let me hand you one. I'll pause for a second while we get those sheets out. Okay, I think everybody's got a sheet now. So, Nate, would you read me anything off the sheet that has sine squared in it? I think you'll find there's only one thing. Now, does that just instantly solve my problem? No, but it's the only thing on the sheet that says sine squared. So I could get this sine squared alone. Do you remember this the other day where I would like solve for one of these? I called it rearranging it. So now the sine squared can be alone by if I subtract cosine squared from both sides. So this is your process. You go grab this off the sheet. You then solve for one of them. Look, I got sine squared alone. And what is sine squared? It's 1 minus cosine squared. That's a fact you could just write on your sheet. It's a fact just as much as the other one is a fact, because it's just the other one rearranged. I just subtracted cosine from both sides. So that means wherever I have a sine squared, I can put 1 minus cosine squared. So, instead of sine squared, put 1 minus cosine squared. And let's use x because the sheet is in theta, but our problem is in x. Okay, so again, big picture, what happened? I knew that this had to be a cosine. So I went to my sheet and figured out how could I get sine squared to be cosine squared? There was only one thing on the sheet that had sine squared in it. I wrote it out. I got it solved for sine. See, sine is alone, cosine's canceled, got 1 minus cosine left. So I replaced my sine with a 1 minus cosine. That's what just happened in the big picture. Could you have done that? Well, by a week and a half from now, you'll have to, or you're not going to do so well on the test. I hope you could make those leaps. Need cosine. How do I get cosine? Must be able to swap out sine for cosine. Go to the sheet, figure out that sine is 1 minus cosine. Now, I got to multiply this all out. This is this times this, and then this times that. And then rearrange it so the squared thing is in front. That's next. And these two can go together because they're like terms. And negative 2 plus 1 makes negative 1. Now, it took me that long to just get it to be something that can be factored. Now, the question is, can you factor it? See why factoring is got to be like the easy thing? Because we've gotten a whole bunch of work in, and now if I didn't know how to factor, I'm done. It's baby stuck. But I remember this will be 2 cosine times a cosine, because I know how to factor. If you want, I will happily work with you one-on-one until your factoring is solid. Riker, can you tell me if it's a plus and a plus, or a minus and a minus, or a plus and a minus? It's got to be plus minus y.
Because there's a positive and a negative.
Yep. I would say it this way. If there's just a negative at the end, doesn't even matter what this is. If there's a negative at the end, it has to be a plus and a minus.
And then it's got to be 1.
It's got to be 1 times 1 makes 1. Now this has to be it, or there is no answer, because all of those choices were forced. So that's either works or it doesn't. So I'm going to check it, and I go, that times that makes 2 cosine squared. That's what I wanted. The outside and the inside. Oh, wait, I've got negative 2 cosine and positive 1. That should have been a negative cosine. Dang, mine, I said it was for sure right. I was wrong. I checked it. That's why you check it. This should be minus, and this one should be plus. So that the 2 cosine x will be positive. Minus 1 cosine x makes positive cosine x. Okay, I didn't even think about how that plus and minus can be reversed until I checked it. That's why you got to check it too. All right. Now, what we aren't asking you to do yet, but we will later, is say equals 0, and then you got to set this equal to 0, and you got to set that equal to 0, and you got to do circle trig on both of them. So if your circle trig sucks, if you're like, I don't know how to do cosine x equals a half, I do. Cosine's adjacent to hypotenuse. I know where to draw it. I can figure out the angle. Let me just do it for you super quick. Cosine is adjacent over hypotenuse. That's got to be square root of 3. What's across from the square root of 3? 60. So that's pi over 3. So the answer is pi over 3. But if you can't do that at the end of the unit, you're toast. So again, maybe it's a good time to think about retaking our last test. And I think the only test you can retake right now is our last. Oh, or when did I give you back? You might be able to take the last 2 tests over again if you wanted to. But anyway, we're not doing this today. Don't freak out. It's just the factoring part, pretty much, and the common denominators. Oh, wait. This one's still a factoring one. Which can be factored, the top or the bottom? The top, because it's got the squared in it. Factor that. Because if you can factor it, you should. Thinking about revamping my favorite saying, but then I'd need a new poster. But instead of if you can factor it, you should, I could be like, if it factors, factor? I don't know if that's probably not any better. Okay, 1, 1, plus, minus, cosine, cosine. That's all you got to do. And on the bottom, I have a 1 minus cosine. Coincidence? I see the same exact thing here and here. That's not a coincidence. That was set up on purpose so that will cancel that. And so your final answer is just 1 plus cosine. That makes sense? Okay. On to the next one. Factor and simplify. What on earth are they talking about? I can't get this to cancel this unless those are both cosines. Or both sines. And so you think to yourself, is there a way to replace sine squared with something so it'll turn into cosine? Yes. If you have a short-term memory, you know that we just did this a second ago. Sine squared plus cosine squared equals 1, and then you solve it for sine squared. Get sine squared alone by minusing cosine squared from both sides. And that cancels that, and sine squared is alone, and it equals 1 minus cosine squared. So I can put 1 minus cosine squared. 1 plus cosine squared. Now, danger right here. A lot of people think you can just cancel it right now. You cannot. The time when you cancel it is after it's factored. Did you factor yet? No, you did not factor yet. So you can't cancel yet. Factoring. I hope that's becoming automatic. 1 minus cosine, 1 plus cosine. And now they're exactly the same, and I can cancel them. So let's back up. So remember in this blue problem, why couldn't I factor it in the first place? Because these had to both be cosines to be able to cancel them later anyway, so and there was nothing I could factor that into except sine times sine. And that doesn't help. So I replace it with 1 minus cosine. I would just memorize this one. It's going to happen so often that sine squared is 1 minus cosine squared. If you have to, you go down like this on the sheet and you solve it, but this is really the slow way. After a while, you got to start going, sine squared, oh yeah, that's 1 minus cosine. It's worth memorizing. It's going to come up over and over and over. Same exact thing for cosine. If I said, what's cosine squared? It's 1 minus sine squared. That's just this rearranged. All comes back to that one. But whenever I see cosine squared, I think, do I want to put in 1 minus sine squared? On to the next. And we're almost done. This is just, hint, you will need a common denominator. Do you get that I could multiply by the other denominator, but wouldn't it be way easier to just multiply this one by cosine? Why? Because then it's cosine squared, and then they have a common denominator. Now, this way totally works, but there was a better way. Let me just show you something. Do you remember a second ago that... Oh, wait. I'm wrong. The way that I showed you was the best way. It is true that this is 1 minus cosine squared x. But you can't cancel these when they're in the middle of a plus or a minus problem? So then I thought I was going to be able to cancel those right there because I could make sine into cosine, like I was just telling you about that. But this can't cancel this because it's part of a subtract problem. So, bad idea. Back to the one I said before. Because now they have a common denominator. Now I know it's really messy, but cosine secant minus sine squared all over cosine squared. Can I make it easier? Yes. What could I replace secant with? This is something you have to get good at. Like, well, I could switch it with this or I could switch it with that. What's the sister function for secant? Cosine. So could I put 1 over cosine right here? And then cosine times 1 over cosine? Do you see where I'm going with this? I could swap out secant for 1 over cosine. And cosine is just cosine, of course. And then the cosine could cancel the cosine. And all of that is just 1. 1 minus sine squared over cosine squared. And wait a minute, it gets even better. Anybody see it? What's that? Cosine squared. And if that's cosine squared, then that's cosine squared over cosine squared. And that's equal to 1. The whole thing simplifies down to 1. Holy crap. Now it'd be super easy to look over at somebody else's paper on the test and see that the answer was 1. And so you're like, oh man, I'm just going to write 1. If you don't have the work that goes with it, then you don't get the points, of course. It'd be way harder to copy the person's work. All of this work here. But the answer was just 1. And this last one, I would let you say I know that that's cosine. And if this wasn't a proof, proofs need you to write out one more step. You'd have had to write cosine squared over cosine squared. But this was not a proof, so I would not have needed you to have to show that last step. 1 equals 1. If it was a proof, it would have to look like that. Okay. Well, you've made it, and then all of a sudden, there's this. Now, to me, right away, I don't see anything I can factor, because if I can factor it, I should. And I don't see any denominators even, so how the heck am I supposed to make this into common denominators? I don't see any denominators. So it seems like it's kind of off theme for today. There's no factoring, and there's no denominators. Can you do anything with this? Well, it says it equals this. It must be that I'm just supposed to prove that that is true. So I must have to do some kind of a swap off of the sheet. Come on, you can do this. Which one of them should I pull out? How about this? First of all, which of the two sides is more complicated? Well, duh, this side's more complicated. So that's the side I should simplify. So then within those three, cosine, cotangent, and sine, I've given you a pro tip, and it was make everything in the sines and cosines so stuff will cancel. So what's the one thing that's not sine or cosine? Cotangent. And so I should probably swap that out. And I know you may not have it memorized, but you got a sheet. Look on the sheet for cotangent. Cosine over sine. And I know at first I was thinking, oh, something's going to cancel right away. It does not, but we're not done yet. Yes.
Why is cotangent cosine over sine? Isn't that just tangent?
I think you were thinking of sine. Sorry. I think you were thinking of tangent. Here, let's put them side by side. Here's tangent. Sine over cosine. And cotangent should be like a flip of that, because remember how these are the sisters of each other?
Oh.
Okay, so then it's just flipped. Cosine over sine. That's why I put, instead of cotangent, I put cosine over sine. So, I know, it feels like it should cancel, and if I flipped it, it would cancel, but that's not it. I thought about the same thing, too. All right, so I really wish something would cancel right now, but it's not canceling, so I guess I just put cosine times cosine together, and that makes cosine squared. Hint, the reason this problem is here is because today we're talking about getting common denominators. Do you get all of a sudden we have things that have denominators? If you see things that have denominators, you should be thinking, oh, maybe I'm supposed to make a common denominator. Mason, what do you think I should do?
Times it by sine.
You are correct, sir. Sine x, sine x. And now I've got a common denominator, and now somebody else has to make a leap. If that's sine squared, I now have cosine squared. Somebody sees it. I know you see it. Just say it. What can you replace with what? 1. Where does 1 go? Yeah. Dad, it's right on the sheet. What's cosine plus sine? It's 1. It's right on the sheet. Sine squared plus cosine squared. It's 1. I know they're reversed, but when you're adding things, it doesn't matter whether it's cosine plus sine or sine plus cosine. So that all is 1. And then somebody has to make that last leap for us, because you can't leave it as 1 over sine. What's the final answer, Jack? 1 over sine is cosecant. You are correct. Look at that. It's simplified down to just one thing. And that's typically what you're supposed to do, but I even knew it's supposed to come out to cosecant because it says so right there. It says it equals cosecant. I'm just going to bring it all the way down, and I am allowing kids to do that. You should technically have written equals cosecant, equals cosecant, equals cosecant, equals cosecant, but I would allow, if you draw a line like this, to imply that you had copied cosecant all the way down. Because do you get on a proof, you can only mess with one side, and I did. I only messed with the left side. So the right side is just going to stay the same. And you have to end with something that is exactly equal on both sides. And this would be the showing your work part. And it involved a common denominator, which is why that problem was there. All right, I need to get you into your homework and do the first couple with you. This was not an easy day, I get it. But it brought factoring full circle from just simple things to now you're factoring trig. And also common denominators, which at the beginning of the year, some people couldn't add common denominators when they were just simple numbers. Now you're doing common denominators with trig. All right, so let's get that worksheet open. Garrett, would you read me numero? Oh, he's still getting there. George, you got the worksheet open? Okay, I'll come back to you in a second. Somebody got it open? Come on, help me out. Yes. Claudia, what'd you get? What's number 1? cosine squared x
plus 2 cosine
plus 2 cosine
x
x
plus 1.
plus 1. Ooh, I bet they want me to factor it. What does the directions actually say? Just factor it?
In 1 through 4, write each expression in factor.
Factored form. Okay, good. So just factor it. That's all I gotta do. I'll pause for a second while you guys factor that. So this worksheet is monstrous and intimidating, and so we're taking it in 2 days. You were only supposed to be assigned 1 through 8 today, but you may cross off number 8. We'll just keep it a little simpler. Just do 1 through 7, and I'll make sure that I do 1 and 2 with you, so you're only left with a few problems. Okay, but they aren't super easy. It's about factoring and common denominators. All right, this one should have been cosine and cosine. And they're all pluses here, so then this must be a plus and a plus. And then it has to be a 1 and a 1. I would check it though. Cosine squared. Outside, inside is 2 cosine x. That makes sense. 1 times 1 is 1. Okay. Number 2. Now I'm going to ask George, would you read me number 2, please?
1 minus 2 sine of x.
Is it squared or just sine?
Just sine.
Just sine, okay. Oh,
Minus
x minus.
cosine squared of x, which is the last place in the parentheses.
Like that?
No, the 1 minus.
Oh, all of that?
Yeah.
Okay, got it. Is that it? All right. Now, they were throwing you a softball here. They were trying to see if you'd notice you can't factor that until you get them all to be one function. And they even made this into 1 minus cosine so that you could very easily, whoa, that was close. Power just flickered in here. So that you can very easily swap that out. And do you know it yet? I said you should just memorize these because they're going to come up a lot. Jack, you know what that is? It is sine squared. If you're like, well, I didn't know what that was. You go to the sheet. The only thing that says cosine squared on it is sine squared plus cosine squared equals 1. And then you go, oh, I guess I can just rearrange this one and get this alone. So I subtract sine squared from both sides. So it's, or sorry, wait, I want 1 minus cosine squared. So I subtract cosine from both sides. And sine is the same as 1 minus cosine. Oh, yeah, sine. Okay. So if that gets swapped for sine, then I'm putting it first. And then I'm putting this next. Pro tip for factoring. Always put your squared first. Always put your other thing next. And always put your whole number last. It's so much easier to factor when it's like that. Trying to factor them when they're backwards is really hard. Now, just do one step at a time. I keep telling myself that about my giant national board thing that I'm doing right now. 60 hours. Ugh. So I did a little bit more this weekend. I took another step and another step. If you just keep on taking one more step, eventually you get there. So what do I start with? Parentheses. And then I know it's sine and sine. It has to be because it makes sine squared. And then I think, oh, he always says to look at this last number to see whether you should use pluses or minuses, and I have to use minuses to make it come out negative here, but positive there. And then it has to be a 1 and a 1. If you just keep taking one little step at a time, it's not that bad. That's factored. That's all I asked you for, just to factor it. Okay, there'll be somewhere you're going to have to get common denominators and add them together. Let's do 1, 2, skip a few and get one of those in. Garrett, would you read me one of the ones that wants a common denominator? Probably like 4, 5, or 6 or something.
Actually, 4. So
Okay, read me number 4.
4 tangent squared of x minus 4 over cotangent x plus secant x times cosine x.
Oh, it's not addition.
Times.
Oh, those are all times?
No, the last.
Just the last ones?
Yeah.
Okay, like that times that? Got it, okay. All right. One step at a time. Ooh, I know the secant sister function. Do you know secant sister function, Garrett? Secant?
That would be 1 over cosine.
1 over cosine, yes. And 1 over cosine times cosine. Think about it. And it's equal to 1. I see how they're setting up to be able to factor this thing. That's just 1. This is 4 tangent squared. You can factor that. We will later. But then this piece, we have to make that be the same function. You can't factor it unless they're all one function. So we got to get that to be tangent. Do you get this is really 1 over tangent? And if you have a fraction with 1 over tangent in it, it's kind of like having 2 over 1/3. It's the same as 2 times 3. You know, you change it from a divide to a times and you flip the bottom one. Does that ring a bell? That's one of the reasons the top 20 and the basic 20 are necessary, is for little moments like that. So you can go, oh, so if there's cotangent in the bottom, then that means there's 1 over tangent in the bottom, which means that the tangent's going to go to the top. 4 tangent. And there, I leave you with that because you can factor that. Hint. You probably are going to know that it's got a minus and a minus in it. And it obviously has to have a tangent in it. But you can't just have a tangent times tangent to make a 4. That 4 has to be represented somehow. So either you're going to put a 4 tangent, or you could put a 2 and a 2. Oh, last thing. I know this 1 has to be a 1 and a 1. It's the only way you make a 1. So then you just have to figure out whether it's 4 and 1 here. Hint, I don't think it's working. It's if when I multiply it out in my head quick, that's not working. So it must not be a 4 and a 1. All right, probably gave you too much help on those, but leaving you with just 1 through 7, and we've done a few of them. Take the time. Answer key for this one, since it's not a proof, the answer key will be posted. Proofs is just too easy to get stuck, go look, oh, there's the answer. Here, I think it's okay to see the answer keys when they're not proofs. All right, that's all I got for you for today.